going to, I'm not going to wait. I want to be mindful of the time of everyone that actually came on time. So let's go ahead and get started. So I'll just, good morning or good afternoon, whatever it is on the planet for you right now. Today, I think we have a really cool topic. It's something that has come up on workshops that we've done before. It's natural language converted to SQL or Cypher using a large language model. And really today, what we want to do is discuss a few approaches and implementations that we have done and our partners who are presenting today have done as it relates to text to several different query languages. We want to take a look at Ponder Labs, and we have Yegor Tarasenko from Ponder Labs here with us. We want to take a look at their approach to DBT, and we also want to touch on how Graphiti acts as a temporal memory tool when thinking about the architecture of your solution in terms of its memory. I have with me Gal Shubeli. He is an AI engineer at FalkorDB. And Yegor, who I presented before, and I'm going to do a short intro in just a second. And Preston, I believe, is going to join us momentarily. Maybe he's having a few issues joining, but he'll be here. And oh, there he is. Let me bring him in. So Preston is joining us as well. Just a little bit about who we are and what we're going to do today. So, hey, Preston.
Hey.
How's it going? Okay, so Preston is a software engineer at Zep, and he's one of the architects that works on the Graphiti project. It's an open source library that builds temporal knowledge graphs in order to aid the context engineering for AI agents. And Yegor, who is joining us, is a data scientist and AI engineer at Ponder Labs. Ponder is all about smart tools and stronger schools. I really like that. And they're building data and AI-powered analytics solutions for the education sector. Excuse me. Ponder's DWE, which is a data warehouse for education, and they also actively contribute to open source AI and data engineering tools such as DBT, Airflow, and FalkorDB. And both Yegor and Preston will share demos of what they do and their approach to the main subject of today, and hopefully touch on how FalkorDB is weaved into that so that you can get the full picture. So it's Gal, myself, Yegor, and Preston, and let's just jump right in. So what we want to do today, we want to show Text2SQL, Text2Cypher, DBT, and agent memory. As always, there's an open Q&A at the end where I'll put up all the questions that we're getting asked so that you can follow along, even for those who are just listening in. And I want to talk a little bit about the core problem and what everybody seems to want and the common denominator between everyone. So the issue we're seeing that a lot of people are facing at its core is how to get the LLM to understand what we mean so that it can adequately produce a query for us. Which kind of leads me to my main point, which is everyone here, or the majority of you, are trying to build a system that enables you to speak with your data, and writing the actual queries to do that is secondary to that objective. And just a thought, I mean, how can you really write a query for a database you're not really familiar with if, say, you're just starting out in a new job? And you would be right to point out that Text2SQL exists, and it is a new, but we found that what works in a demo hardly ever works in a production environment. And the enterprise reality that most of us have has to consider hundreds, if not thousands of tables. And equally as importantly, a lot of the vector approaches that we have seen today don't really capture the relationships between the different schemas that you have. Normally, the solution is asked to retrieve tables, but as soon as you're essentially asking them to do that, the semantic element or capturing the relationships isn't what it was really designed for, and that's where a lot of those POCs tend to fail. So this is really, I think, what the shared pain point that we're seeing at FalkorDB. It's the common pain points that we're seeing when we're running POCs and thinking about solutions like this. And in order to talk more about our implementation and get right to the examples and how we approach this, I'm going to hand over to Gal. He's an AI engineer at FalkorDB for those who are just joining us right now. And he's walking you through essentially two demos, which is our approach to text-to-SQL and text-to-Cypher. So Gal, take it away.
Thank you, Dan, and thank you, everyone. So before we dive into how we implement the text-to-SQL and conversion between NLP questions or natural language questions to query each query, if it's Cypher or SQL. Let's start with real life example that we face as FalkorDB. We had a POC with large ERP data over the 4,000 tables. Each tables can contain more than 100 columns. Together, they can't insert to the context window. And when the naive way to use vector achieve very low accuracy, around 15, and due to a problem when you search for the relevant tables in the schema or in the database, there is similarity between tables, and you can insert the relationships between tables. In this example, we had a business relationship between tables. But I think the main idea here that when you have some database, relational database, you have schema. You have the tables, you have the foreign keys, you have columns, and you can understand where you stand on. And the LLM can understand the schema and convert it to your query, each database. And the problem is that the schema, if the schema is so large, it's hard to insert it to the context, and it's hard to search for the relevant tables in the schema with the connection between the tables, and maybe there is other tables that not semantic connect to your table. Okay, so let's jump next, Dan. Let's jump into what we bring into the table with the QueryWeaver. Our product to text-to-SQL is called QueryWeaver. We took the schema of the relational database and represent it into the graph. We use the semantic layer. Each column in each table is embedding with description, and we represent the schema into the graph with structure representation, with the ability to multi-hop reasoning between tables, and with the ability to represent different database in different graph with multi-tenancy. And this is what give us the opportunity to do text-to-SQL with very large databases, schema that over 4,000 tables. Okay, let's talk about our approach and how we did it in text-to-SQL. So we begin with user question. And we want that the LLM and our system to understand the user question. Usually, when the user asks with natural language question, there is different part in the question that related to different tables, and we want to decomposition this question to different table. So we use LLM to break this question into different parts of tables. I will get into it in the next slide. Next, we use the graph, FalkorDB graph, to find the relevant tables. we use the LLM to convert it into SQL with the addition of long-term memory and like query the database and give a natural language answer to the user. So the first part is to break the question into descriptions. We give to the LLM with relevant prompt and ask the LLM to understand the question with alignment to the database and create table descriptions and column descriptions that will be matched to the description that we created in the ingestion of the graph. So in that way, we're closing the gap between the description of what we search and the description of our database. So this is the way that we try, or like we overcome the semantic gap between descriptions. So we end up this step with embeddings of descriptions of tables that relevant to the user questions and descriptions of columns that relevant to the user questions. Different tables, different columns that maybe give us the tables that we need to answer the question. So the following part is using the graph. FalkorDB graph, this is our browser visual representation or visualization of our graph. You can see you can see the ontology that we used in Text2SQL in QueryWeaver. There is tables, node of tables and node of columns. You can see the properties of one column. You have the type, the key type, primary key, description, embedding, and the relationship between them. Like table has columns reference to other columns, and that way we can connect everything in our database, in our graph database. So this is the representation, the structured representation of the schema of relational database. And what I want to focus here is how we can like traverse here without knowing the root. Look at this example. We have tasks table and we have leads tables, and they are connected with primary key that called user ID, and it's part of the user's table. If the user questions reference to tasks and leads, and we want to do a join, we have to extract the users tables. And in our way to traverse the graph, we do a variable length traversal, and we extract every entity in between. In that way, we can create the joins with tables that not necessarily semantic relevant to the connect to the user question, but relevant to create a rightful or like right syntax of SQL. In addition, we extract the semantic relationships here, and we also extract spheres. We assume that every tables here that have a similarity to the user questions descriptions, maybe the connection or like the first hop connection between them can be useful to the LLM to construct the SQL. Okay, so the next part is to construct the SQL. We use this relevant table that we extract from the graph as a GraphRAG approach. We bring it as a structure with the relationships to the LLM and explaining how to do how the syntax of the database is work, like which databases work, if it's MySQL or Postgres, and each database that you can think, and ask him to build the SQL. It's important to say that for us to bring into the live like correct syntax SQL. We also ask him to explain and do analysis or reasoning to the creation of the query and validate it afterward, and maybe we need retry. So it's okay. For everything work well and like improving over time, we use memory. We talk about it in our last sessions. We use Graphiti as long-term memory and personalization and understand like the environment of the user. And we also custom the memory with Graphiti and add a task performance tracking each query. If it succeeds or not, we save it into the graph and like learning it from time to time and not. We want to like avoiding similar errors over time. And that's also a very important thing to create a graph. We use it also as a different graph in our multi-tenancy environment. Let's continue. Okay, that's overall of Text2SQL. I hope that you understand. If you have a question, we have time after. I will show you the demo, 1, 2 questions after I explain about Text2Cypher. So Text2Cypher is very similar approach to what we did with Text2SQL. Overall, we want to give the schema to the LLM and ask him to perform the task of creating the query. In Text2Cypher, we do ontology detection. We understand the ontology of the graph because Cypher is the language of graphs, and we convert it into Cypher with ontology and with the prompts and create Cypher, query the FalkorDB graph, give the retrieval to the LLM, and give a natural language answer. Okay, so let's go to demo. I will try to show my screen.
Yeah, I'm going to stop mine. And then now when you share your screen, actually, I'm going to overlay you so that people can actually see you as well. Go ahead, go.
Okay, so one moment. I think let's start with the demo of the Text2Cypher until it's like loading. You can share your screen and like show the video and like we do it afterward.
Oh, sure.
Sorry about that.
You're talking about me, right?
No, I'm talking about Dan. Dan, show
Sure.
the demo of Text2Cypher.
Sure.
Okay, so let's start with the Text2Cypher and then we will continue to the QueryWeaver demo, like the Text2SQL. So I capture a short video of how we do Text2Cypher. This is our browser, the visualization. We can ask question in the chat. It will be published for everyone. This is the graph of the demo CRM. I will show you in the QueryWeaver. Then he like understand the ontology, create the cipher. We can like run the cipher and see the examples. Just for explanation, I ask him to connect between. I ask him which columns connect between two tables, like the task tables and the users tables, and then like he told me which column that I need to use. This is something that's very amazing because in that way we don't need to understand cipher. We can like ask things, get a cipher, and maybe use this cipher as a beginning, and like continue to traverse the graph and understand our data better. Okay, Let me show the QueryWeaver. Okay. Do you see my screen?
Yeah.
Okay, this is our QueryWeaver. I think I showed you this in the last or like before the last one of the last webinar. You can ask anything. We build a demo CRM. Anyone can ask question, and I will show you how it's work. What we spoke about in this webinar. When we ask question, he analyzes the question. It's break it into descriptions, create the SQL, and then he will query the database. Give him some minutes because I like deploy it now. Execute the query, generate user friendly. So you create the SQL. It's a SQL that contain several joins. He need to understand like the relationships, uh, like we told you, and then he extract the data and give you like tables and like natural language output. Oh, we can like continue asking questions, but this is this is the implementation and the demo, and I encourage you to like try it because it's out for everyone. That's it.
Super. I'm seeing a few hands raised and some questions, so let's pull those through to the end, and I'm more than happy to address those in a little bit. Yegor, I'm very happy to introduce you and give you the stage so that you can present. If for whatever reason the video doesn't load, we have it backed up, so just tell me and I'll play it on my side. But other than that, very happy to have you share your screen and show us what you built.
Sure. Happy to be here. Thank you for inviting me to the event. Thank you, Dan. Thank you. Thank you all for joining us. Yeah, and basically I will share my screen. All right. I hope you see the DBT right. Perfect. So hello everyone. My name is Igor Tarasenko, and I'm data and AI engineer at Ponder. At Ponder, our tagline, as Dan already said, smarter tools, stronger schools. We build data and AI-powered analytics solutions, especially for education organizations, and we help them turn complex information they have into actionable insights and make better decisions for their students. We also regularly contribute to open source projects, especially those that related to data and AI, including DBT, Airflow, and obviously FalkorDB. Our main goal is to make advanced technology more accessible and widespread across the education sector. That's why it's so important for us to support open source projects. One of those projects is DBT. Many of our partners and clients rely on it to manage their data infrastructure and really big data ecosystem. And today I will share how FalkorDB helps us to solve one of the key challenges that emerges as DBT ecosystem grows in scale and complexity. So you can see DBT docs. I'll explain in a minute what exactly it is. For those unfamiliar, DBT, I would say that in recent years, in the recent times, it pretty much became the backbone of the modern analytics engineering. It allows different teams, different data teams to transform their raw data into clean, reliable data sets with just pure SQL and version control based practices. There are a couple of things here, are a couple of things that make DBT so powerful. So first of all, lineage tracking. You have all of your SQL models, and you like basically, I think in the past we just wrote SQL and created tables manually, and then just there was some job that inserted script, etc., etc., and basically it causes a lot of different problems. And now each piece of your SQL logic is a different model. It's basically a DAG, so it sort of looks on circle dependencies and prevents circle dependencies, and you can basically trace from each of your source tables to your data merts and to your leave tables. Another important thing for DBT is testing. Tests in general are built-in feature for DBT. You can write tests and you can make it generic for different tables and for different sources, for different seeds and snapshots. Basically, I think in the recent times, all of us understood that data quality is not a game. It's like a crucial, important piece of data infrastructure. So here it's built in. Modularity, right? I think one of the important concepts of programming in general and data engineering in particular is DRY, don't repeat yourself, and DBT with the help of Jinja and other templates make it possible to write the logic once, and then if you have to implement it for different tables or for basically make 5,000 union alls for different teams or something, you can use those macros and those templates. And the last one is documentation, this thing that you can see on your screens. All of this, like this perfect UI was generated automatically. Obviously, I haven't coded anything manually except for SQL code. And in this documentation, I can see basically all of my SQL logics, and I can see models, I can see tests, I can see seeds, I can see basically all of my all the parts of my data infrastructure. And besides, I can see some interesting details. I can see the script, I can see a compiled script, etc., etc. And obviously, the first thing that I talked about is lineage, which is great, and it's probably the crucial part of working with data in the recent times. So surprisingly, that's exactly where we hit the wall. While DBT docs gives us this really beautiful and rich lineage graph and generally like this lovely visual, it still cannot answer to some complicated questions that we received from our clients or from our partners, especially when they have really big DBT ecosystem. So let's imagine that like this project is relatively small. We have about like 40 tables. I think we know a couple of examples when companies have a couple of thousand. But yeah, let's imagine that we have some really complicated project for now, and we have like 3,000 different models and seeds, etc., etc. And I would like to know, I would like to make blast radius analysis, right? What does it mean exactly? It means that the particular question is, what's the complete blast radius if I need to rebuild the STG students table? Show me all downstream models that would be affected, including their materialization type. Right, so we have some STG students table here. Let's see it on the lineage. So we can see that's the table. We can see the source. We can see all the downstream dependencies. So great, right? We can partially answer that question. But what about materialization type? Some of these models are views. Some of these models are tables. Some of them are incremental tables, and many more options. So there are basically two possible solutions. We can either, spend just hours or, like in some cases, probably days, by clicking on different nodes and view documentation and like checking whether it's view or table and going back. The second option is we can create some sort of Python parser, for example, take basically DBT has two metadata files. So this parser can take these files and parse them and answer our questions. The problem is that, first of all, it will take time, even if you do it with AI, and obviously all of us do it with AI now. You still have to rebuild your parser for each new question, and it takes time, it takes work, and it basically just takes much more effort to be implemented. So that was exactly the moment when we realized that DBT is inherently in graph, right? Because there are nodes, which are models, sources, seeds, different tables and views, snapshots, etc. There are edges, which are basically dependencies between different models. And there are attributes, right? Attributes like materialization type, like when it was built, who is the owner, what is the script, etc., etc. Many different things. So we suddenly realized that it would be great to take all this graph with all its metadata and load it into graph database. And here was the question: what graph database should we pick? And pretty, I think, like a couple of minutes after we started searching, we found FalkorDB, and it basically had it was great. It excelled in all the parameters that we were looking for. It's truly open source. Its performance was amazing. It has Redis ecosystem, which is great because I think the vast majority of us are familiar with that ecosystem. It has modern architecture. It's super suitable for AI, which I will touch in a second. And it has amazing support. I think I think like basically it's one of those moments when support connected me, and not me connecting support, because I had a couple of Cypher questions. So great, we have FalkorDB on the one hand, and we have DBT manifest and catalog files and like just bunch of metadata on another hand. And what do we do now? Basically, that's exactly the point when Ponder comes in. We created parser for DBT manifest and catalog to take it and basically load it into FalkorDB and then we can have the whole metadata in FalkorDB. So we can see that that's a Falkor UI. We can see that right now we have limited rows to 100. So it's not all the models, not all the seeds and snapshots and nodes that we have in DBT, but we can see that it basically pretty much the lineage that we've seen. Obviously, we changed a little bit different names. We changed edges types, etc., etc. And now we have we have Cypher, we have query language in order to extract the data and answer our questions programmatically and not just drag and dropping different things in DBT docs. So that's great. And probably we can write a Cypher query and, after Gal slides, we can even translate English to Cypher and it will be fairly fast, but it still can be problematic for people because a lot of first of all, people don't know Cypher. Like not everyone knows Cypher. Secondary, even if people will start running different Cypher queries, it will take some time to understand what are the nodes and what are the particular types of edges, etc., etc. So it will perfectly suit some particular cases, but we want to basically just sort of take Gal's idea and implement it, just integrate LangChain, like in our case, integrate LangChain and being able to talk to our graph database in plain English. And that's exactly when we created this beautiful Streamlit Ponder chat. So that's exactly the interface with your graph database. Let's take this question that we have, the first question that we talked about, and ask our board what does it think about it. So we can see that there are basically two parts for this agent. It creates the Cypher query, and then it goes to our FalkorDB and executes it. Obviously, there is a prompt that we provided to our agent. We explain a little bit about different edges and different nodes, and like we sort of connect the business value of different types of edges and what is called in FalkorDB. And we can see that it sort of starts playing this ping pong with our FalkorDB engine. It asks something, then it probably in this particular case, it doesn't receive anything. It tries again, and then again, and it just again and again trying to recheck itself. We can see the full chain here, and it keeps going. I already it will be probably it will take a couple of minutes. I already asked that question before. You can see that it's exactly the same UI, and I just run this query like 20 minutes before. So we can see exactly the same. It started running a couple of Cypher queries, and then it basically received the necessary information, received the necessary metadata, and we can see the whole blast radius for STD students. We can see level 1, level 2, etc., which is great, but we are more interested in visualization types. So we can see table and we can see views, and it's pretty much great. We can there is some summary here that can be interesting. And all right, great. So like we can see that in this particular case, it took 36 seconds. Our live demo also done, and it took 1 minute and a half. Let's check some another question that we talked about before. So let's talk about dependency complexity, right? We would like to know which models create the longest dependency chains in our project, and what's the maximum depth of any single lineage path from source to final math.
I don't want to interrupt you because this is really great. Maybe you just want to show us one more question so that we have time for Preston's presentation as well.
Perfect. Right. So I think one more questions. I think I will pick the interest one. Job orchestration. Let's imagine that we orchestrate our DBT in Airflow or any other orchestration tool, and we would like to split our 2,000 models to a couple of different jobs. And we would like to keep looking for dependencies and make sure that there are not circle dependencies between different DAGs or between different pipelines. So basically, we have this 2,000, 3,000 models, and we would like to split it to different jobs. And we would like to either to run all of them in parallel, or if it's impossible, then we would like to know dependency between these pipelines and like what we have to run first of all, and then what depends on the first run, etc., etc. So I already executed this question as well, and we can see that after a few dozens of Cypher queries, it basically came to understanding that we have to build 5 parallel pipelines. Not all of them are parallel, but let's like we have job number 1, we have job number 2, job number 3. All the models are listed right here. And then after it basically listed all the 5 jobs that we asked for, we can see execution strategy. We can see the job 1 must run first of all because it's probably like preparation data, etc., etc. Then we have 2, 3, and 4 that can run in parallel, and then we have job number 5 that depends on all of them and has to run the last. So that's great because just FYI, it's really hard thing to do manually because you have just a lot of different options and a lot of different pipelines possible. And basically, yeah, that's pretty much the demo. What started as just a static metadata has now become living and trustful and conversational knowledge graph. And that's exactly what we like doing in Ponder. We like doing data work feel easier, and this project is exactly part of it. And obviously, FalkorDB made this possible by giving us fast, flexible graph engine that exposes the true shape of a DBT project. You're more than welcome to try it yourself. You have all the code is open source. You're welcome to go to our GitHub page. You're welcome to go to our Ponder site, to our newsletter on Substack. We should like this blog post is also there, and obviously you're welcome to find us on LinkedIn. Yeah, so that's pretty much all I have for now. And thank you for listening, and yeah, fire away with the questions.
100%. We're going to pull all the questions together in a Q&A and pitch them to you when we arrive. For now, Preston, more than happy to hand over the reins to you so that you can also show us what you guys built.
Awesome. Thank you. So can everybody see my screen?
Yep.
Okay, cool. Yeah, so I just have to move my video away. So hi, I'm Preston. I'm a software engineer at Zep, and I'm one of the creators of Graphiti, which is our open source project that builds and manages knowledge graphs to aid in agents or AI agent memory and context management. Um, so kind of start a bit talking about our motivation behind building Graphiti. You can kind of think about agent memory and this like context, broader context engineering as being either an evolution of RAG or maybe part of RAG, depending on how you define those terms. Um, but the reason why we saw a need for Graphiti specifically is because we looked at more traditional methods of RAG, and a lot of them were built around this idea of having a corpus of knowledge that either changes infrequently or doesn't change at all. It's based off of static documents, and it's this idea of like you ingest in a pipeline and then you kind of try to figure out knowledge based on searching that database. Whereas we see like as agentic AI agents became more popular, agentic workflows became a lot more popular. It became more of an agent as an aid and a tool in your day-to-day workflow. We noticed that things were a lot more iterative. You're not just searching a static knowledge base, you're providing knowledge, you're providing feedback, and we needed to give agents a way to grow and understand from that. And so Graphiti is built from the ground up, um, basically optimized for adding new knowledge while not destroying old knowledge is basically the two kind of like key components and ideas. And so you can think about traditional RAGs being more about batch processing. Maybe it's about like kind of building summaries or like, other forms of memory or like more naive forms of memory. Maybe you're like just summarizing a few old conversations, but then those summaries don't update. And this is the goal of this is to be not that. Um, and part of that too is a lot of times when knowledge is updated in other like RAG systems, it's a replace, right? Oh, this Wikipedia page got updated. Get rid of the old Wikipedia page. This is now the source of truth. Whereas a lot of that like breadcrumb trail about like the mistakes you made or the things that were wrong or the information that is changing is also important. Just because my favorite food has changed doesn't mean that my favorite food in the past is no longer relevant information. And so we've also built our knowledge graphs to be like temporally aware. So the idea that like we have this log trail of information that is evolving over time, but still maintaining what we can from that. So Graphiti is a temporally aware knowledge graph framework designed for AI agents and dynamic environments. So that's kind of our big pitch. So we have real-time updates. We do bitemporal tracking because when you start getting down to the nitty-gritty, you realize that there's kind of two components to this timeline that you're building. There's the component of, I told you what my favorite food is, but then later, if I tell you what my favorite food is when I was 5, you can think like, oh, that's now not relevant to today, even though you told me it later. So you have these kind of two timelines of like the system timeline of when it found out information, but also this world timeline of when this information actually happened. And keeping those separate and tracking both those separately is also like very important for being able to reason over this information. Um, in terms of like getting information out of the graph, we use a combination of semantic search, which is vector-based, BM25, which is keyword-based, and other like graph traversal and like graph algorithms, including community detection, BFS, in the future, PageRank, and then those types of things. Which is also why FalkorDB is super useful for this, is because they support all of those different search types and make it really easy to use and implement them. I can get into this more in a bit, but we also allow custom entities to like skew your knowledge graph to be like more domain specific. So the core architecture of Graphiti has like most knowledge graphs, it's built around nodes and edges. So the system will start by basically being an API entry point that gives you the ability to like what we call an episode, add an episode. So episodes can be either JSON data structure, they can be messages, or they can be text data. And at the high level, Graphiti is kind of built to abstract away the graph, say, hey, add this episode, or hey, get information relative to this query. And then all of the cool graph stuff will be done for you and will be kind of figured out under the hood. So once you add the episode, we actually also store that episode in the graph. So we have like a full log trail of all the information that was added, which is useful for either getting exact explicit pieces of information or for rebuilding the graph if that becomes necessary. So nodes, which we extract as entities from your information, and facts are both automatically extracted by an LLM under the hood. So you might say, an example, hey, Kendra loves Adidas shoes. And then under the hood, we would extract, oh, hey, Kendra is a node. It's a person. Kendra has this relationship, loves, with Adidas shoes, which is also another node. And it could be a product as like its label. And then to help with the temporal extractions, we actually look at the timestamp of the messages as well. So you see how in this example, you don't have to provide, hey, I'm Kendra, I like Adidas shoes from this date to this date. As you see, this ingestion is a bit old, but basically it will look at the current timestamp, or you can provide a timestamp of when the message was said, and it will do all of the temporal extraction and reasoning around those. And then edges are similar. We have fact embeddings. We have what we call like hyperedge support. And so we can build a really like integrated graph where you can have like an idea and like triplet facts being kind of attached through multiple nodes and edges as well. So temporal intelligence, I've kind of gone over this before with the two timelines. And basically in data that's stored as a valid at and invalid at date. And this is in that world timeline, like when these things are actually true or when they stop being true in the real world. And then created at and expired at timelines, which is the system timeline about like when you actually express to the agent about this information. And in addition to this temporal extraction, we also do this edge invalidation. So like, hey, maybe you say, oh, I used to love pizza, and then later you say I don't love pizza anymore. So that invalidation to expire that is actually done automatically under the hood. So the agent will find facts that are contradicted by the current information that was just extracted and will set those expired at and invalidate at dates as well. So we mostly have like a three-pronged search strategy, which is when you're trying to get information out of the graph. So you've added your episodes, the graph is built, and now you want to give your agent the ability to reason over this context. And so our three-pronged strategy is around semantic search, which is vector embedding based, BIM25 full text search, and like I've discussed before, some graph traversal algorithms as well. And then those different methods of searching are all fed into re-rankers, which will try to figure out based on what your message is, which of these pieces are actually most relevant to the current query. And again, this is another like useful thing for why FalkorDB is like really good for this stuff is all these algorithms are super fast. They're all supported in FalkorDB. And so that's kind of like one of the reasons why they're our default graph provider for our MCP server.
Preston, I'm really sorry to cut you off. I do want to leave a few minutes for Q&A.
Yeah,
I just see
no
like
problem.
really great slides here. Do you think those are slides we can share with
Yes,
everyone?
I can share them afterwards. Yep.
Perfect. So I'm just gonna I don't want to interrupt. Just please finish up and let's leave around 10 minutes for Q&A.
For sure.
And
yeah, I'll
really great
finish up
stuff.
then.
Sorry to interrupt.
Yeah, no problem. I'll share these slides. We also have plenty of docs, and I'll be happy to answer questions as well. And just the last thing, Graphiti's, like I just mentioned, it's available through an MCP server. So it's very simple if you just want to hook it up to your agent, and FalkorDB has an in-process database. So you can just use the MCP, install it, and it'll just work right out of the hood with FalkorDB. Cool. Thank you.
Yeah, you're really, really great stuff. I just out of personal curiosity, like you guys built the presentation with an LLM, right? Like, so this,
Yes.
that's a
Yeah.
really, that's a really cool idea for how to do that. I really like
Yeah,
that.
it's actually so we have a bunch of without going to we have a bunch of like information and like other presentations we've done. We're just like, hey, make a presentation that you can just go back and forth and it'll
It's
yeah.
very smart. It would have saved us time when making slides because it was more interactive and really cool. Great. So how about this, guys? We have some time left. If you guys are fine, we could go over the rest of the FalkorDB team. More than happy to go a little bit over to address as many questions as we have. But if you do have another engagement coming up in 10 minutes, that's totally fine. Super appreciate it if you can hang on. What we did do in our last workshop, and people really seemed to like it, was instead of just reading the questions here, there's no way to put them up on the screen. What I did was I just shared our canvas and where the questions actually are, and I'm also going to read them for people that are just listening in. So let me just share my screen. And the only problem is that you can only see me, which is kind of annoying. Okay. So everybody can see my screen?
Yes.
My audio? Oh, okay, perfect.
Yeah.
So excellent. I'm seeing most of the people that joined are still here, so this is really great. I got to tell you guys, it's the fastest we've gone through 15 minutes. So I had a really nice time, and I'm really sorry I had to cut you off, but normally those Q&A sessions tend to be really interesting, but it was really I'm really happy you guys were able to come and share this with us. If anybody wants to jump in to answer the question, please feel free. And of course, for anybody watching, these are the LinkedIn profiles. I'm encouraging you to expand your network, get in touch with them. And if you found any of this valuable, just if you could, it really helps us all collectively if you start a repo so that it reaches more developers. With that being said, let's jump right in. I have the questions ready on screen. First question, not seeing a name attached. Usually there's a name attached, but if it's your question, then you probably recognize it. So for those who are only listening in, the first question is, does what you build work for complex schemas around 50 tables with many relations? I assume it's in relation to QueryWeaver and what we've built. So Gal, I think it's a good question you want to answer.
Yeah, right. Before I answer the question, I just want to say amazing work, Preston and Igor. It was wonderful and very interesting. Yeah, the main idea behind QueryWeaver and the text-to-SQL that we show today is many relations between a very large amount of tables, um, larger than 50 tables, but 50 tables with many relations, it's suitable to represent by the graph and traverse by the graph, and the extraction is what we it's where we shine, you know.
Yeah, I agree. I think also in the introduction that we did, we're just going to mark this as completed. In the introduction that we did, I think that was one of the points that we were trying to make, that in real life scenarios, you don't normally encounter such a small amount of tables, normally reserved for a POC. So short answer, in addition to what God said, is yes.
Yes.
Next, sorry. The next question comes to us from Alexander. One, well, yes, definitely. It's all recorded. It's on YouTube tomorrow and Discord and all the rest of the socials. So no worries, definitely recorded. Text-to-SQL. What if there are some business logic rules, like if column 1 equals value number 1, then column 2 can only be value 2, etc., etc. These rules can't be extracted from the database schemas. Where is the place for these rules? Gal, do you want to?
Yes. Actually, this is what we did on the POC that I'm talking about in my part of the talk. Um, in addition to what I showed you today, we can add layers into the graph. We can add a layer of the business rules, connect them to the relevant tables, relevant columns, connection between tables, and use them when we extract tables. For example, in our POC, it was necessary to extract similar tables that connected under folders. Like if you have sales, different kind of sales, it's under same folder in the customer hierarchy, and we add this layer to the graph, and when one table from this folder is extracted, all the tables is extracted, and the LLM get the relevant instructions to perform the query. So the answer is you can save it into the graph in the graph as a business connection or business rule as a layer, and you can like add different layer that related to different kind of logic that you want to insert to the graph.
Super. We have another question from Adam. Is using QueryWeaver MCP in Claude Code or similar AI dev tools the fastest way to test QueryWeaver locally on my database and ask questions and evaluate the answers?
Yes, I think it's for me also. And yes, so the fastest way is to use QueryWeaver.ai. It's on cloud. You can try it and connect your own database. For now, it's Postgres or MySQL. You can use the MCP. This is on open source. You can use our GitHub repo and run the MCP server. If you have other database, not Postgres or MySQL, you can like contribute and add your database and use it. But we working to add more databases.
Let's see, another question I have pulled here from Asaf. What is the difference between training my own large language model, in parentheses, they noted Sonnet or GPT, to answer questions via SQL and FalkorDB doing the same thing? I hope I sort of understood this question.
Yeah, I will answer that. I think training a large language model is very expensive and took some time. You need the resources. And after you finish it, it's relevant to a certain time or certain point where your data is reachable. When you use SQL and FalkorDB, it's more dynamic, and you can use the ability of LLM to understand language, natural language, and use the database that can change over time. I think in low price, if you compare between the training, and you can like use FalkorDB and SQL to get your data and achieve similar things, but with more dynamics and less and reduce the costs.
Great. I think we have time for another question.
Maybe there is questions to about Graphiti or like DBT.
We have a team monitoring the questions, and I think all the questions I'm seeing on screen and the one that we actually got. So do you want to take this last one, or?
I can. So I will say, do you have to supply the schema, tables, and field descriptions in advance in order for the model to understand which fields to select? The answer is yes. But we insert to the QueryWeaver the ability to investigate the schema from the relational database and to extract the description. If there is no description, he built the description on flight. And we also use a taxonomy. So if I didn't say it on the talk, but on my slides, but each tables come with the taxonomy, and that gives the LLM the ability to understand enums or like which type of data he need to create and filter when he create the SQL. So we like retrieve from the database some samples and give the LLM explanation of how to do the query.
Great. I do realize we're 1 minute over the line. There's one question I think, Yegor, during your presentation, you did mention that some of what you showed us, and I think Preston, you alluded to that as well. There are examples to what you've shown that people can play with. So what I would propose that we do, afterwards, we normally send a recap of everything that people saw here. We pull together all the questions and we write a sort of summary to everything that's been asked here. So I would like to append links to whatever you guys want to share with whoever came here today, so that they can play with it afterwards. And I would just, I realized this would have been a question for you, but I think you sort of touched on that during your presentation. So there are examples of how this was built that people can take a look at, and we'll be sending those after the event. So guys, how was it? Did you have fun? No, they look tired. It was fun.
Oh,
Yeah.
Yeah, definitely. I think it was great.
Super.
A lot of good.
So guys, before we,
Amazing.
in the spirit of holidays, we do want to, so this is not advertised anywhere. This is really sharing with the people that joined us today. So through to the 5th of September, if you have a up and running FalkorDB cloud instance and you've spoken with our product team or are planning to, then you qualify to 2 free months on our startup tier. All you got to do is just go to the get a demo page, note your instance and write Black Friday, and we'll get in touch with you so that you can take advantage of it. So this was sort of like our gift for Black Friday. And with that being said, just I want to thank Preston, Yegor, and Gal for your time for joining us today. This is the 9th time, I would say, in the last 7 months that we've held workshops like these. And the next one that we have is going to be the last one we do for 2025 to sort of recap everything that's happened this year with GraphRAG, with graphs, everything that we've poured into developing FalkorDB. And we want to share some of the mistakes we made, some of the projects we worked on, and sort of the predictions we have for 2026. And I would like to use this platform to, of course, extend an invitation to you guys if you'd like to come on board to present more of what you guys built sometime in the next quarter. And just to wrap everything up, as always, this is recorded, shared with everyone on YouTube tomorrow. And unless anybody else wants to add anything to what I said, wish you all a great day, and I'll see you next time.
Thank you, Dan.
Cheers, guys. Have a great rest of your day. Hope you guys have fun.
Bye-bye.
Bye.